What if I told you that in 1970, one stubborn drag racer from Illinois proved that Chevrolet's cheapest, weakest transmission was actually faster than their most expensive performance unit? That the two-speed economy box that came in your grandmother's Impala could destroy the legendary Turbo 400 in a quarter-mile sprint? This is the story of how Bill "Grumpy" Jenkins outsmarted General Motors with their own forgotten transmission. Picture this. It's a Saturday night at National Trail Raceway in Ohio, 1970. The air is thick with tire smoke and racing fuel. In the staging lanes, million-dollar factory teams are prepping their pro-stock machines, all running heavy-duty 3-speed automatics or 4-speed manuals. Then Jenkins rolls up with his Vega, and the tech inspectors can't believe what they're seeing under the car: a Powerglide, the same transmission suburban housewives had in their grocery getters. The paddock erupts in laughter. By the end of the night, nobody's laughing anymore. Jenkins just ran 8:60 seconds and reset the pro stock record. Here's what makes this story legendary. Bill Jenkins didn't just stumble onto something. He systematically dismantled 50 years of automotive engineering dogma using nothing but a stopwatch, a calculator, and a transmission everyone else threw in the trash. The Powerglide wasn't supposed to be fast. Chevrolet never marketed it for performance. Hell, they actively discouraged racers from using it. But Jenkins saw something everyone else missed, and it would revolutionize drag racing forever. To understand why Jenkins' Powerglide discovery was so radical, we need to travel back to 1950. General Motors was developing automatic transmissions to compete with Ford's successful automatic offerings. The engineering brief for the Powerglide was simple: cheap to build, smooth for comfort, reliable for everyday driving. Performance wasn't even on the list. The two-speed design used a simple planetary gear set and a torque converter. First gear had a 1.76:1 ratio, second was direct drive at 1:1. That's it. No overdrive, no fancy electronics, no multiple clutch packs. Just 2 gears and a prayer. Meanwhile, Chevrolet's performance flagship was the Turbo Hydromatic 400, introduced in 1964. This was a beast of a transmission. 3 forward speeds with ratios of 2.48.1, 1.48.1, and 1.1. It could handle 450 pound-feet of torque stock. The TH400 had multiple clutch packs, complex valve bodies, and weighed 135 pounds dry. Racing teams loved it because it was bulletproof. Funny car teams were putting 2,000 horsepower through modified TH400s. The Powerglide? It weighed 95 pounds and was rated for maybe 300 horsepower on a good day. Chevrolet's own engineers recommended it only for 6-cylinder engines and small block V8s, making under 300 horsepower. By 1969, Pro Stock was the hottest class in drag racing. Factory-backed teams from Chrysler, Ford, and GM were spending millions. The rules required stock-appearing bodies and production-based engines, but everything else was fair game. Teams were running trick 4-speed manuals with lightning rod shifters or beefed-up TH400s with trans brakes and 5,500 RPM stall converters. More gears meant keeping the engine in its power band longer. That was racing gospel. First gear multiplication got you off the line, second kept you accelerating, third gear took you through the traps. Every performance manual, every racing guru, every factory engineer said the same thing: more gears equals faster elapsed times. Enter Bill Jenkins, 6'2", perpetually scowling and allergic to conventional wisdom. They called him Grumpy because he had the personality of a cactus and about as much patience for stupid questions. Jenkins wasn't a factory guy. He ran a 2-bay garage in Malvern, Pennsylvania, later moving to Illinois, and built engines for local racers. But Jenkins had something the factory teams didn't: an obsession with efficiency. While Ford and Chrysler were throwing cubic inches at the problem, Jenkins was sitting in his shop with a slide rule calculating parasitic losses. Here's where Jenkins's genius revealed itself. He realized everyone was focused on the wrong metric. They were obsessing over keeping engines in the power band, but nobody was calculating transmission efficiency losses. Every time an automatic transmission shifts, there's a power interruption. The engine has to drop RPM, the transmission has to release one clutch pack and engage another, and the whole drivetrain has to cope with the shock. In a TH400, you're shifting twice, once from first to second at about 1.2 seconds into the run, then second to third at around 3.5 seconds. Each shift costs you about 0.2 of a second. Not in shift time, the TH400 could bang gears in 300 milliseconds. The loss came from power interruption and drivetrain shock. Jenkins started testing with a borrowed Powerglide in late 1969. His theory was elegant. Eliminate one shift, eliminate one power loss. The Powerglide would shift once at about 2.8 seconds into the run, then pull all the way to the finish line in high gear. But the math had to work. The first gear ratio of 1.76.1 was lower than the TH400's 2.48.1, meaning less mechanical advantage off the line. Jenkins compensated with rear axle gearing. Where TH400 cars ran 410.1 or 430.1 rear gears, Jenkins bolted in 5.13.1 or even 538.1 ratios. The final drive multiplication was similar, but now he had one less shift to worry about. The first tests were disasters. The stock Powerglide exploded on the third pass. The aluminum case split like a beer can, the planetary gear set turned into shrapnel, and Jenkins spent 2 hours picking transmission parts out of the oil pan. But he noticed something before it failed. The car was running identical 60-foot times to his 400 test mule, but gaining 2 car lengths by half-track. The theory was sound. The execution needed work. Jenkins went to work on the Powerglide like a surgeon. The stock aluminum case was replaced with a modified cast-iron unit from a 1962 Corvette. The planetary gear set was upgraded with heat-treated 4140 steel components. The factory used a simple single-disc torque converter rated for maybe 2,500 RPM stall. Jenkins had ATI build him a custom 10-inch converter with a 5,000 RPM stall speed. The stock valve body got recalibrated for lightning-quick shifts at exactly 7,200 RPM. The weak point was the input shaft, a spindly piece of 1020 steel that twisted like licorice under real power. Jenkins had Summers Brothers machine him billet 300mm steel shafts, 40% larger in diameter. But here's where it gets interesting. The Powerglide had an unexpected advantage nobody had considered. The TH400 used a Simpson planetary gear set, a complex arrangement with multiple sun gears, planet carriers, and ring gears. The power path through first gear involved 2 separate planetary sets. That meant more rotating mass, more bearing surfaces, more friction. The Powerglide used a simple Ravigno gear set, 1 sun gear, 1 planet carrier, 1 ring gear. The power path was direct. Jenkins calculated the Powerglide had 18% less rotating mass than the TH400. In drag racing, rotating mass is the enemy. Every pound of rotating weight requires horsepower to accelerate. The rebuilt Powerglide went into Jenkins' 1970 Vega Pro stock car in March. The car was a missile, all steel body, narrowed 3 inches, full tube chassis, and a distroked 331 cubic inch small block Chevrolet, spinning to 9,500 RPM. Everyone else was running 430 to 450 cubic inch big blocks. Jenkins was giving up 100 cubic inches, but saving 180 pounds. The Powerglide was part of that weight savings, 40 pounds lighter than a race-prepped TH400. The first race was the Gator Nationals. Jenkins qualified third, ran consistent 990s, and lost in the semifinals to Ronnie Sox's Hemi Cuda. But people noticed something odd. Jenkins was crossing the finish line at lower RPM than anyone else, yet his trap speeds were identical. The Powerglide was pulling from 5,000 to 8,500 RPM in high gear, a 3,500 RPM spread. The TH400 cars were shifting into third at 7,200 and only pulling to 8,200, a 1,000 RPM spread. Jenkins' engine was accelerating longer in each gear. By June, Jenkins had the combination sorted. The Powerglide was shifting at exactly 1.95 seconds into the run at 7,400 RPM, then pulling to 8,800 RPM at the finish line. The car was running 9.60s at 142 mph. At the Summer Nationals, he faced Dick Landy's factory-backed Dodge Challenger. Landy's 440 wedge had 100 more cubic inches and a perfectly tuned TH727 3-speed. They left together. Jenkins pulled a fender by 60 feet, and by the time Landy shifted into third, Jenkins was gone. The Vega won by 3 car lengths. The Powerglide had struck. Now, here's the kicker. Chrysler engineers were in the stands that day with data acquisition equipment. They couldn't believe the time slips. Jenkins was running identical 60-foot times to Landy, 1.29 seconds. Both cars were making about 650 horsepower, but Jenkins was consistently 2 to 3 hundredths quicker to the finish. The Chrysler guys ran the data through their computers 3 times. The conclusion was always the same. The Powerglide single shift was saving more time than the TH727's gear multiplication advantage could overcome. Word spread through the pits like wildfire. Jenkins tried to keep the Powerglide secret, even fabricating a fake TH400 oil pan to throw off competitors. But racers started noticing details. The transmission cooler lines were in the wrong place. The shifter only had 2 forward positions. The car sounded different, that distinctive Powerglide whine at launch. By September, the secret was out. Grumpy Jenkins was beating million-dollar factory teams with a $100 junkyard transmission. The physics behind Jenkins' success was brilliant. Let me break down exactly why the Powerglide worked. In a perfect world, keeping an engine at peak power during the entire run would yield the fastest times. That's why Formula One cars have 8 or 9 gears. But drag racing isn't Formula One. You're accelerating from 0 to 150 mph in under 10 seconds. Every millisecond counts. The TH400's first to second shift happened at about 55 mph. The second to third shift occurred around 95 mph. Each shift involved releasing one set of clutches and applying another. Even with perfect preparation, you're looking at 300 milliseconds per shift where zero power reaches the wheels. The Powerglide shifted once at about 75 mph, 1 power interruption instead of 2, but there was more to it. The Powerglide's torque converter was more efficient at high stall speeds. Jenkins' custom converter had a tight coupling above 5,500 RPM, almost like a manual clutch. The TH400's larger converter had more slippage, wasting power as heat. Jenkins estimated the Powerglide was putting 8% more power to the wheels above 100 mph. In a 10-second race, that's the difference between winning and watching taillights. The gear ratio spread told another story. The TH400's ratios, 2.48, 1.48, 1.0, had massive drops between gears. First to second was a 40% RPM drop. Second to third was a 32% drop. The engine had to recover from each shift, building RPM back up. The Powerglide's single shift from 1.76 to 1.0 was a 43% drop, but it happened once. Jenkins tuned his engine's power band specifically for this ratio. Peak torque at 6,200 RPM, peak power at 8,200 RPM. The engine was always in its sweet spot. Let's talk about the modifications that made the Powerglide survive. The stock unit was rated for 160 horsepower and maybe 200 pound-feet of torque. Jenkins was putting 650 horsepower and 500 pound-feet through his. The cast iron case could handle the stress, but everything inside needed upgrading. The factory sun gear was sintered iron, compressed metal powder that was cheap to manufacture, but weak under load. Jenkins used a billet 440 steel sun gear, heat-treated to 58 Rockwell hardness. The Planet gears were similar upgraded. The factory used 3 planets. Jenkins added a 4th for better load distribution. The clutch packs were completely redesigned. Stock Powerglides had 4 friction discs in the high gear clutch. Jenkins ran 9 discs, alternating between steel and carbon fiber. The forward clutch got similar treatment. The apply pistons were modified for quicker engagement. Stock pistons had a cushion spring to smooth shifts for comfort. Jenkins removed them and installed solid aluminum pistons with no cushioning. The shifts were violent enough to leave bruises, but they were quick. The valve body was a masterpiece of modification. Tom Williams at Tom's Transmission spent 3 months perfecting the calibration. Stock Powerglides shifted based on governor pressure, a mechanical system using flyweights and springs. Jenkins wanted electronic control. They installed a trans-brake valve that locked first and reverse simultaneously for launching, then released into first gear. The 1-2 shift was controlled by a Hobbs pressure switch monitoring engine oil pressure. At exactly 95 psi, corresponding to 7,400 RPM, the transmission would shift. No variance, no hunting, perfect every time. The 1970 season finale was the World Finals at Dallas International Motor Complex. Jenkins faced Sox and Martin's 4-26 Hemi Cuda in the final. Sox was the best driver in the sport. His Chrysler had factory backing, and the Hemi was making 675 horsepower. Jenkins' 331 small block was down 100 cubic inches and 25 horsepower. Vegas had Sox favored 3.1. They staged. The tree dropped. Jenkins left first by 0.02 with a perfect .500 light. The Vega pulled a fender immediately. Sox's Hemi was screaming, but every time the TH727 shifted, Jenkins gained a car length. The Powerglide shifted once at the 330-foot mark, then pulled like a freight train. Jenkins crossed the finish line at 8.627 seconds at 158.43 mph, a new pro stock record. Sox was 0.02 behind. The Powerglide had won. The next morning, Jenkins' phone rang off the hook. Racers wanted Powerglides. Transmission shops that had been throwing them away suddenly had waiting lists. The problem was supply. GM had stopped Powerglide production for performance cars in 1972. The only source was junkyards, and those dried up fast. A transmission that cost $50 in 1969 was selling for $500 by 1971. But wait, there's more. Jenkins' success forced other teams to rethink everything. Don Nicholson started testing a Powerglide in his Ford Maverick. The Ford C4 transmission was similar to the Powerglide, 2 speeds, simple design. Nicholson applied Jenkins' principles and started winning. Chrysler developed a 2-speed version of the Torque Flight, specifically for drag racing. Within 2 years, half the pro stock field had switched to 2-speed transmissions. General Motors' reaction was fascinating. They'd spent millions developing the TH400 as the ultimate performance transmission. Their own advertising called it the choice of champions. Now, some grumpy racer from Illinois was proving their economy transmission was faster. GM engineers came to Jenkins' shop, studied his Powerglide, and couldn't argue with the physics. In 1971, they quietly started offering a heavy-duty Powerglide option for Camaros, and Novas ordered through the central office production order system. These Copo Powerglides had some of Jenkins' modifications from the factory. The financial impact was staggering. Jenkins sold his Powerglide modification recipe to ATI for $50,000, serious money, in 1971. ATI started producing super Powerglides that could handle 1,000 horsepower. They sold thousands at $20,500 each. Tom's Transmission became the go-to shop for Powerglide builds, growing from 2 employees to 30. Jenkins himself started Jenkins Competition, selling Powerglide parts and complete transmissions. By 1975, he was grossing $2 million annually just from transmission sales. Let's dive deeper into the technical revolution Jenkins sparked. The Powerglide's success challenged fundamental assumptions about gear multiplication. Engineering textbooks said more gears meant better acceleration. The math supported it. Keep the engine at peak power, multiply torque through gear reduction. But those calculations ignored real-world factors: shift time, drivetrain shock, parasitic losses from additional rotating mass. Jenkins proved that in a 10-second drag race, efficiency trumped multiplication. The weight difference was crucial. A fully built TH400 for Pro Stock weighed 165 pounds with converter. Jenkins' Powerglide weighed 118 pounds. That 47-pound difference was all rotating mass. Using the standard 8-1 rotating to static weight penalty, that's equivalent to removing 376 pounds from the car. In Pro Stock, where cars had minimum weight rules, that meant Jenkins could add ballast exactly where he wanted it for weight distribution. The reliability factor was unexpected. TH400s were considered bulletproof, but in Pro Stock trim, they required rebuilding every 20 runs. The complex valve body would wear, the multiple clutch packs would glaze, the 3 planetary gear sets would develop play. Jenkins' Powerglide went 50 runs between rebuilds. Fewer parts meant fewer failure points. The simple Ravigno gear set was almost indestructible once properly built. Jenkins ran the same transmission case for 3 complete seasons, unheard of in Pro Stock. Testing revealed another advantage: the Powerglide was more consistent. With only one shift point to manage, there was less variation run to run. The 400 cars might vary by 0.03, depending on shift quality. Jenkins' Powerglide varied by less than 1/100th. In bracket racing, where consistency matters more than outright speed, Powerglides became mandatory. By 1975, 90% of bracket racers ran Powerglides. The converter technology Jenkins pioneered revolutionized automatic racing. Stock Powerglide converters were 11-inch units designed for smooth street driving. They'd slip 20% at full power, wasting energy as heat. Jenkins's 10-inch custom converter used furnace-brazed fins, anti-ballooning plates, and a billet steel hub. Above 5,500 RPM, efficiency exceeded 97%. That technology trickled down to street performance. Today's $3,000 converters use Jenkins' design principles. Here's something that'll blow your mind. NASA studied Jenkins' Powerglide for the Space Shuttle program. They were designing the shuttle's auxiliary power unit transmission and wanted maximum efficiency with minimum weight. The Powerglide's simple planetary design became the basis for the APU gearbox. The same transmission that powered grocery getters helped launch the Space Shuttle. Jenkins consulted on the project, earning $100,000 for 3 months' work. The cultural impact went beyond racing. Jenkins proved that smart engineering beats brute force. While Detroit was in a cubic inch war, 454s, 460s, 472s, Jenkins was winning with 331 cubic inches and clever transmission choice. He inspired a generation of racers to think differently. David could beat Goliath with the right slingshot. Speaking of David versus Goliath, let's talk about the 1972 Winter Nationals. Jenkins faced Dyno Don Nicholson's 429 Boss Mustang in the final. Ford had spent $2 million developing that Boss 429 program. Jenkins was still running his garage-built 331 and Powerglide. The Ford guys were so confident they had champagne on ice. Bad move. Jenkins cut a perfect light, the Powerglide shifted flawlessly at 7,400 RPM, and the Vega crossed the stripe at 9.48 seconds, a new national record. Nicholson was 100th behind. The Ford Champagne went unpopped. The Powerglide domination continued through the 1970s. Warren Johnson, Larry Lombardo, Bob Glidden, all the Pro Stock legends ran Powerglides. The transmission became so synonymous with drag racing that announcers would say Powerglide equipped like it was exotic. Chevrolet's cheapest transmission had become racing royalty. But the real validation came from GM itself. In 1980, they introduced the TH200 transmission, essentially a modernized Powerglide with updated materials and electronics. The engineers admitted they'd been inspired by Jenkins's success. The TH200 used the same simple two-speed design, the same Ravigno gear set, even similar ratios. It was a factory acknowledgement that Jenkins had been right all along. The Powerglide's influence extended internationally. Australian drag racers imported Jenkins-built Powerglides for their pro-stock Holdens. Japanese teams bought them for their rotary-powered RX-7s. A transmission designed for 1950s American sedans was winning races on every continent. Jenkins received letters from racers in 15 countries, all wanting Powerglide secrets. Let me put this in perspective with some hard numbers. Between 1970 and 1980, Powerglide-equipped cars won 73% of all NHRA Pro Stock events. They set every national record from 1971 to 1978, the quickest Pro Stock run of the decade. Warren Johnson's 798 at the 1982 Winter Nationals used a Powerglide. The transmission Chevrolet marketed as smooth and economical had become the most successful racing transmission in history. The modification industry that grew around the Powerglide was staggering. By 1975, there were 17 companies making aftermarket Powerglide parts. You could buy billet cases, custom gear sets, exotic friction materials, electronic controllers, a cottage industry worth $50 million annually, all because one stubborn racer questioned conventional wisdom. Jenkins's notebooks from this period reveal his obsessive attention to detail. He logged every run, noting temperature, humidity, barometric pressure, shift points, and 60-foot times. He discovered the Powerglide shifted quicker at 140 degrees fluid temperature than 180 degrees. That led to custom transmission coolers with thermostatic controls. He found that ATF Type F fluid provided better shift quality than Dexron. Every racer switched to Type F overnight. The longevity of Jenkins's discovery is remarkable. Today, 50 years later, Powerglides still dominate certain drag racing classes. Modern pro mods run Powerglides capable of handling 4,000 horsepower. The basic design hasn't changed. Still 2 speeds, still a Ravigno gear set, still that single perfect shift. Companies like ATI and TCI sell brand new Powerglide cases machined from billet aluminum. A complete Pro Mod Powerglide costs $15,000. The technical evolution continued into the 21st century. Modern Powerglides use carbon fiber clutch packs that can handle 500 pound-feet of torque per disc. The valve bodies are CNC machined to tolerances of 0.01 inches. Shift times have dropped to 150 milliseconds. But the fundamental principle Jenkins discovered remains unchanged. In drag racing, less is more. Here's a detail that shows Jenkins's influence. In 2010, GM was developing the new Corvette Z06. The engineers were testing transmission options for drag strip performance. They tried the 6-speed manual, the new 8-speed automatic, even a dual-clutch setup. Then someone suggested testing a modernized 2-speed based on Powerglide principles. In quarter-mile testing, the 2-speed was consistently quickest. GM didn't produce it. Marketing would never approve. But Jenkins' ghost was still haunting their test track. The human side of this story matters too. Jenkins received hate mail from Teach400 suppliers who lost millions in sales. He got death threats from racers who'd invested fortunes in 3-speed setups. But he also got letters from weekend racers who could suddenly compete because Powerglides were cheap. One letter from a disabled veteran said Jenkins' Powerglide setup let him return to racing after losing his left leg. The simple 2-pedal operation was perfect for his condition. Jenkins retired from driving in 1975, but continued developing Powerglide technology until his death in 2012. His final project was a Powerglide with variable ratio technology, essentially infinite ratios between 2:1 and 1:1. It never saw production, but the prototype ran 7.50s in testing. Even at 76 years old, Jenkins was still innovating. The economic impact deserves examination. Before Jenkins, a competitive pro-stock transmission cost $8,000 to $10,000. A built Powerglide cost $2,500. That democratized the sport. Weekend racers could suddenly afford professional-level equipment. Pro-stock fields grew from 16 cars in 1970 to 64 by 1975. More racers meant more spectators, more sponsors, more money flowing into the sport. Jenkins didn't just change transmissions, he changed drag racing economics. Consider the physics one more time. The TH400 had gear ratios mathematically optimized for acceleration, 3 speeds to maintain optimal engine RPM, multiple clutch packs for torque capacity. Everything about it screamed performance. The Powerglide had 2 gears designed for 1950s economy, yet it was faster. Why? Because Jenkins understood that theoretical perfection doesn't win races, real-world efficiency does. Every component you add introduces loss, every shift costs time, every pound slows you down. The Powerglide won by subtraction. The legacy continues evolving. Electric vehicles are using similar principles. The Tesla Model S Plaid uses a single-speed transmission, no shifting, no complexity, just direct drive efficiency. When Tesla engineers were asked about it, they cited drag racing Powerglides as proof that single speed could work. Elon Musk probably doesn't know it, but his cars use Jenkins's philosophy. Modern Pro stock has moved to 5-speed Liberty transmissions, but they're essentially Powerglides with 3 extra overdrive ratios for shutdown. The first 2 gears maintain Powerglide ratios, 1.80 and 1.0. Racers still call first and second the Powerglide gears. The additional ratios only engage after crossing the finish line. During the actual race, they're running Jenkins's setup. So what can we learn from Bill Jenkins and his weird Powerglide obsession? First, question everything. The entire automotive establishment said 3 speeds were faster. They had computer models, dyno tests, millions in development. They were wrong. One guy with a slide rule and a willingness to experiment proved them wrong. Second, simplicity has value. In our modern world of 20-speed transmissions and infinite complexity, remember that sometimes less is more. Jenkins won by removing components, not adding them. Third, efficiency trumps brute force. While competitors added cubic inches, Jenkins optimized what he had. His 331 cubic inch small block beat 450 cubic inch big blocks because his drivetrain was more efficient. That's a lesson for any engineering challenge. Don't just make it bigger, make it better. Finally, persistence pays off. Jenkins' first Powerglide exploded. His second one failed too. Most people would have given up, admitted the experts were right. Jenkins kept refining, kept testing, kept believing in his calculations. By the time he was done, he'd revolutionized the sport and made millions doing it. The Powerglide story reminds us that innovation doesn't always come from corporate R&D departments with unlimited budgets. Sometimes it comes from a grumpy guy in a 2-bay garage who's willing to question everything. Jenkins saw potential where others saw junk. He turned Chevrolet's forgotten economy transmission into a racing legend. He proved that weird ideas, properly executed, can beat conventional wisdom every time. Today, when you see a drag car launching down the strip, remember Bill Jenkins. If it's running 8 seconds or quicker, there's a good chance it has a Powerglide or its descendant helping it get there. That thunderous shift you hear at half-track? That's Jenkins' legacy, still winning races 50 years later. Not bad for a transmission designed to get groceries. What's the most unconventional modification you've seen actually work in racing? Drop a comment below and share your story. If you enjoyed this deep dive into drag racing's most unlikely hero, hit that subscribe button for more stories about the rebels and renegades who changed motorsports forever. Until next time, keep questioning conventional wisdom, and remember, sometimes the weird solution is the right solution.